Okay, so critical path analysis. This is the last chapter that we will be looking at for decision for the International A-Level. Thank you again to Dr. Frost and Mr. Andrew Blackett for creating this lovely PowerPoint. Okay, so here it is. It's really exciting. We are on the last one. Now, some of you may have used CPA, especially in computing, because planning a project, making, it's about time management and what's effective. Okay, so, few terms, okay? When we model a project, we have something what's called a precedence table. This is a precedence table here. It shows which activities depend on what. For example, would you, if you're building a house, these are the list of things that we have to do. Would you decorate the house before planning the budget? No. Okay, would you construct the roof before getting planning permission? No, of course not. Okay, so what we would do is we would go down and see what they depend on. Now, right now with this house, we can have a conversation and we can negotiate on this. In the exam type questions, there will be no room for negotiation. It will be very clear in which order you have to do things, okay? For this example, there is a bit of negotiation. For example, some people might get the finances in place before they apply for planning permission to buy the land. Does that make sense? Okay. Some people might... okay, there are some things that we definitely can't speculate. Could we put windows and doors in without building walls? No, because it's impossible, isn't it? Okay, so we're going to have a few... 60 seconds. Let's see what we think could go where. Off we go. Yeah, you may. Who wants to be a millionaire? No. So we're playing Who Wants to Stay With This all week for detention because I didn't do all my homework. That's what we're playing. Who? Everyone in the room bar Vivian. I know, even Guy didn't do all of her homework, to be fair. Guy didn't show her the homework. It was pretty marvellous. I've given him an extension till tomorrow. That was their only homework for the whole class. It is. Yeah, so every day they could go away and use it. I gave them this on Sunday. But I was... You done chapter 7, now you're doing chapter 6? Yeah, we're just following Andrew Blackett's way. Yeah. How are you? Well, I've got linear programming video on YouTube, and if you would like this for any of your children, this is all the linear programming questions for, before they changed it in 2018. Yeah, so that all of our mocks are, I know, there's actually 15. But they're really good, because you've got to, like, oh, they are? Ooh,
like the religion,
yeah.
holy grail kind of thing.
Well, that's what's coming up. But Faris is struggling a little bit because he keeps saying that he's going home doing past papers and that he struggles with it. So I was like, this is a past paper. It's just all about linear programming. These are all past exam questions.
The best way to do it.
Yeah.
Topics first, and then when you get a paper, it's like, oh, boom, boom, boom. Hey, done.
Yeah. Faris missed me this weekend, sir. Faris missed me this weekend. He told me.
Tell lies,
Mr. Jacob. Yeah, what are you doing right now? Who are you teaching? Yeah, what are you teaching?
and it's based in Giselle as well. It's called what is this one? No, it's a good show. It's just like all that's going on in the show is that this guy wants to betray this guy because this guy wants money and this guy wants to steal this guy's wife. It's just a mess.
Right, okay. So, right, we ready? Yeah? Hello? Oh yeah, we're back on. Right, so planning for, apply for planning permission. Does that depend on anything? No. So what we do is we write a little dash, because it doesn't depend on anything. Okay? Planning the budget. Does planning the budget depend on anything? Yeah. What does it depend on? Getting the finances in place. So this is where there is room for speculation here. Here, though, the finances isn't in place. What this means is this is once they've planned the budget, they put the finances in the place of the budget. Okay? So in this context, planning the budget doesn't depend on anything. Okay? Getting the finances in place does depend on the budget. So this depends on B. Okay? Then, next up, we have buying the land. Now, buying the land depends on getting the finances in place. When we look at what it depends on, we look at what is the last thing that needs to happen for this to happen. So we don't have to, if we got down to the bottom of the list, decorating does depend on all of the above, but we're not going to write every single one down. Okay? We're going to think about what is the last thing that has to happen for this to be dependent on. We know that if the last thing that has to happen is this, well, when we go to this, well, what's the last thing that has to happen for this? That. Well, the last thing that has to happen for that? A different word that says this or that. Does that make sense? Yeah, that did not make sense, but it did. Okay, so that is C. Okay, buying the land. Are we on that? No. Digging the foundations. We can't dig the foundations until we've bought the land, right? And sometimes what you'll find a lot of the time, it's always the one above, but not always. So always double check. And then F, building the walls. Before we build the walls, we need to dig the foundations. Okay, G, constructing the roof. Can we construct a roof if we don't have any walls to put the roof on? No. Okay, put the windows and doors in. What do we need for the windows and doors? We don't need the roof for that. We just need the walls, don't we? Yeah? Okay, plumbing. Well, for the plumbing, we need to build the walls. Before we do the plumbing and electric, now this is where it's not a very nice question. We actually got to build the internal walls. Am I going to make a plug socket for example, the bedroom, the lounge? You're not going to fit all the electrics in, are you? Well, you might start maybe half of it. This is where speculation. So I tell you what, when it says the plumbing and electrics, we need to have what? The internal walls, but we're going to change it because that's speculative, isn't it? What do you think we need for plumbing and electrics at least? We need to make sure, have we got the roof? Have we done the windows and doors? Yes, because we don't want to put electrics in if So for the plumbing, we need to definitely make sure that the walls are built. And then for electrics, we're going to have to put the electrics in once the windows and doors are complete, so they don't get wet. Okay, building the internal walls. Now remember, when we say plumbing and electric, we don't mean the whole thing, we mean starting it. Because then when we build the internal walls, we start fitting it in. So building the internal walls is reliable once we've done the windows and doors. And decorating, when are we going to decorate? Yeah, after we've built the internal walls. Perfect. So, as you know, we've made a bit of our own judgment on this. In the exam, we won't have questions like this, okay? Right, so here we go. You've got your own. You are going to a party. Are you ready? What order are you going to do this? Now, this one's an easy one. Are you going to put on an outfit before you shower? No. Okay? So think about what activity depends on what. Off you go. So here we go. What does A depend on? C. Yes, some people we can have C. Some people are only going to RSVP if their friends are going. Okay? Some people just RSVP because they don't care if their friends are going. Their friend invited them, so their friend's there. Yeah. Either will do. I'm happy for you to write a dash or a C depending on, okay? Or you could have written a C, okay? Because some people aren't going to go to a party if their friends aren't going.
So how would you draw that?
Okay. Purchasing your outfit is going to depend on if you're going to the party, right? Yeah. So, it is going to, if you purchase your outfit, that depends on if you're going to the party. Now, depending on which way we're going, are we going to go with this one or this one? Because it will depend now. Okay, or should we do both at a time? If we're saying this depends on, we're going to RSVP if our friends are going, purchasing our outfit is then dependent on A because we RSVP'd, okay? If we are checking that our friends are going, it will also depend on A because we RSVP'd, right? Okay. Then, C, check if your friends are going. What does that depend on? Nothing. Okay. Get a haircut. What does that depend on? After purchasing your outfit? Okay. It could depend on A. As I said, this one is, like, we're just speculating, we're just having a bit of fun, okay? There is no right or wrong answer here. Okay, so we could say this one depends on A. As long as this makes sense, like, the exam questions aren't like this. We're just having some fun, okay? Having a shower, what would that depend on?
Getting a haircut.
What, so if you didn't have your hair cut, you're not showering? That is not okay. You should shower anyway, okay? Because getting a haircut is probably once every 2 weeks for some people. No, but do you see how this is a speculation? You're going to shower anyway, aren't you? Okay? But some people might say it would depend on getting a haircut. So you could write that.
I would say that.
Okay? Then, when are you going to put on your underwear? After you've showered. Now, this is where this makes more sense, okay? Are you going to put your shoes on before you put your underwear on? No. No, because then you can't put your outfit on. Okay? So, F, put on underwear depends if you've showered, yeah? Putting on your outfit depends if you've put your underwear on. Putting on your shoes depends if you've put your outfit on. Travelling to the party depends if you've put your shoes on. Entering the party depends if you've travelled to the party, okay? And obviously if you're going to the party. That could, again, we could be speculative. So, this is just a little bit of fun to just get us looking at precedence tables and what they actually mean and how we can use them to depend on. What we're going to look at is creating an activity network for this. Now, we have to agree which one we will be going with, okay? So, we are going to draw a network. Oh, wait there, I'll take a shot. For this one that we've agreed on, whether it's right or wrong, that's what we're doing. Everyone happy with that? Okay. Right, so now we're going to be looking at drawing activity networks. Now, as you know, I told you all, okay, that we... Okay, so I told you all that we're just going to do it on this one. Is everyone happy with this? Yeah? Now, there's no answer to this. This is completely random. Okay, so forget everything you ever knew. We're going to start afresh. Now, with this activity network, sometimes we have numbers, okay, it's our nodes. Our arcs are the activities, okay? So, first of all, 0 is where we start. Now, whenever you draw these, please use a pencil, because sometimes we have to rub out and go back. Okay, so what do we have to do? So A and C don't depend on anything, okay? Now, forget about what it was. This is what we've been told right now. This is what we've been told. So if A and C don't depend on anything, we have A, we have C, okay? Now, the only issue we have here is that then this goes to 1, okay? It could change to 2. I'm just saying it's the next one. And for this purpose, if you want, we don't even have to fill the numbers in. We could just leave it like this and fill the numbers in later. So, what depends on A? B. So here's B. Okay, then my next one. Does anything depend on B? D. Okay, does anything depend on D? E. Oh, can you see where I'm going wrong? Mm-hmm. Yeah, just honestly, forget everything you know, remember that. Okay, what does E depend on? Yeah, I've done that, so what's next? F. Now you can see this is a really easy one. And then? G. H. And? I, wait there. G depends on H. Oh, that's supposed to be an I, that's why. And then we're going to have I. Okay, and then essentially this would be the finish. Do we notice, though, that C does not have... Oh, sorry, that goes to J. Okay, do we notice that C is not going anywhere? Yeah? Okay? We can't have that. We can't just have it like that. We could join to J, but J is not dependent on C. Okay, C doesn't depend on anything. C just needs to happen. So what we can then do is insert this, which is basically called a dummy line. And we're going to come more into that in a second, okay? It's just saying we have to do C before, because we could say that B is actually dependent on A and C. And this is how it would look like. You wouldn't draw a straight line from here to here. Okay, you can only draw one straight line between two, I don't know what to call these. Well, they are nodes, but I don't know what to call them yet, okay? So, what we're going to do is, this is a really bad example, So we're going to look at some good examples. Okay? Okay, so here we go. This is a network that we've been given. And what we're going to do is we are going to have a look at how we're going to draw this activity. So, this is put in a key in the ignition, put on the seatbelt, drive away, turn on the radio. Now, because activities A and B, they do not depend on anything. When we start at 0, we have activity A, activity B. Now, I'm not sure which one is 1 or 2, okay? So we can just leave them for a second. C is dependent on A and B, and D is just dependent on A. Okay, so I know I can just do this, D, because that's just dependent on A. C, on the other hand, is dependent on A and B. So I need to connect A and B. The only way to do that is by using a dummy line. So this is saying, before I can have an output, and then if this is our end, C. So this is saying, before I can have an output of C, I need to do these two things. I need to do B, and then this came from doing A. Okay? Now here, this means that A would be 2 and this would be 3, because we have to do that. And then our last one is 4. So what does this say? This says when we start, we can do A or B. We get to the next step. Now the reason this dummy is here, because for example, if this took 5 minutes, because we are looking at planning projects, it is all going to be in time. If this took 5 minutes, we're saying to get all the way to this point here, it's still going to take 5 minutes. This dotted line means there's no weight to it. There's no time to it. Okay? So, what we're now going to look at is we're going to actually, this is going to make a lot more sense if we haven't already drawn network, and then we're going to look at what is actually happening. So here we go. We are going to explain the precedence table. So, when we start, we have activities A and B. So that means A and B are dependent on no one. Then, from A, where do we go? We go to C, we go to D. So that means C and D are dependent on A. Now I'm going to have a look at B. Where do we go? B goes to E, but can we see the dummy here? This means that for E to happen, A and B have to have finished. So E is actually dependent on A and B, okay? Every time you go to a node, look what's coming into it to C. Next, where is F? What does F depend on? What comes into F? C. So F is only dependent on C. What comes into G? E, D, and C. Okay, and then lastly, what is H dependent on? So we find H and we look where it's come from. Yeah, G and F. So now what we have done is we filled in the table, okay? Then explain the significance of the dotted line from event 2 to 3. What does this dotted line mean? Okay, so in the mark scheme, you would definitely have to say it represents a dummy activity, okay? So represents a dummy activity, okay? And C and D depend only on A, as we can see, but E depends on A and B. This is what we'd have to write to get the marks, okay? This is what we'd have to write to get the marks. So, this is a network that someone's drawn. Because C depends on A and B, can you see that you've gone from 0, you need A and B, and that outputs C. This is wrong. So, this is why we need to use a dummy, okay? Now, the way I see it, if you're ever drawing and you have curved lines, you're going wrong. Have to use straight lines. For example, if we start at 0, we have A, we have B, okay? Our output is C. What needs to happen? We're going to have to introduce a dummy to then get to C. Okay? Now, all of my lines are straight. I know I didn't use a ruler. Just imagine, okay? Now, then when we order them, we would have to make sure we do this as number 1, number 2, number 3. To be honest, though, in the mark schemes, sometimes they don't have any of these. They just have, it's just a filled-in circle. Okay? They don't have numbers. We are going to take a look at exam questions and the best way to answer them towards the end. So, as you can see here, all my lines are straight lines. This, if you have to draw a curved line. Now, I don't want anyone doing this either. Oh, so here's your 2, yeah? So imagine this is 0 and 1. You can't do this. Ah, look, miss, I've got 2 straight lines. No, that's not going to work. Okay, this is completely and utterly wrong. Okay, so please just make sure, sometimes you have to use a dummy. You're still saying you're going to the same place. And this dummy, what it means is you don't have to add the weights, just the way you have to draw the network. Okay? So, here we go. Test your understanding, please. This is a 7-mark question just for drawing this. 7 marks. Okay, so after walking around the room, some of you have got this completely incorrect. It's fantastic that you're trying. Okay, really good. So, let's draw our attention to something. So someone just said, explain why there are 2 dummies. Those of you saying you don't have 2 dummies, if the question tells you explain why there are 2, I think it's a huge clue that you should have 2. Then, the next one is some of us are really close, and what I'm seeing is at the end, you have 3 different things. This can't happen. You need to have like a start and a finish, essentially. So everything should connect. It still needs to look like a network. Okay, and a network is connected, right? I'm going to give you another minute. Off you go. So this one is probably the best example I've seen of how to do this wrong. Okay? But you'll understand this is a really good example because honestly, even when I first start doing it, I always get to this stage and then I correct what needs to be corrected. So everyone starts like this. Okay, so we know that A and B are not dependent on anything. So here's our A, here's our B. We have a look and C is then dependent on A. Okay, so there's our C. D is dependent on B. So then we draw this, okay? Then, now this is the mistake that people make. Can you see how I haven't started drawing the nodes here? Okay, this is why it cuts your vision off. Let's say I started drawing my nodes here, okay? I then have a look and E is dependent on B and C. So I can do a dummy here, and then E is dependent on that. That's true. If I look at this, what has to happen for this to be completed? C and B. F is also completed. Okay, and then I've drawn that. F. Brilliant. Okay, if you got to here, fantastically incorrect. Okay, absolutely amazing. How do we now fix this? Okay, how do we now fix this? Well, let me give you advice. Don't draw the nose. Okay, is everyone happy that we need, now we've drawn everything, essentially we only need one more now to finish it. So let's say I put it here at F, because F was the last thing that we did in the list here. Okay, D can just make that straight line connecting there. Okay, it's just, that's all I did, look, made a straight line. Yeah, and then for E to F, now as I said earlier when I meant two straight lines couldn't go in, what I mean is if they're coming from the same place, go into the same place. So what we would have to do is, because E needs to get to the end as well, we are going to have to then have another dummy here. Okay. So there we go. So this would be 1, 2, 3, 4, 5, and 6. Now that is 4 marks. So, why 2 dummies are necessary? Well, first of all, E and F are dependent on B and C. Okay? So that's why we need the dummy here, don't we? Then, the second dummy is needed. As you saw earlier, we need to make sure that each of these are uniquely represented, okay, in terms of its events, and it is. If we start here, we need to do all of these steps to finish at 6. So this is ensured that everything has its own representation. Okay? So now we're going to be looking at the early and late event times. Now normally, this is what I was saying earlier, don't get too hung up on these circles, okay? Normally in exam questions, instead of the circles, we're going to have this. Okay, can everyone see the boxes? Yeah? And this is going to be about early event times and late event times. Now, I'm going to show you how to go all the way across, filling in. Remember in Dijkstra's we had to fill it in? Yeah, we're going to have to fill this in. So let's have a look. Okay, everyone. So, what we are looking for is, we're looking at a forward pass. And it's going to calculate the early event times. Whenever we calculate early event times, we're using the largest value. So for example, let's start. Whenever we start, we always start at 0. We're just going to focus on the top row of each box. Is everyone happy with that? Yeah. So we start at 0, and this box here, what's inputted into this box? Either 3 or this line. What is this line essentially? 0, but where did this 0 come from? Why is this 0? Because it's actually B. So how much is it? 5. Okay, so we can, in here, we can either go A is 3 or 5. So, if we have a look, there's 2 ways in here. We calculate both of them, and then we write down the highest. So we've either got 3 or 5 plus 0, because that's how we get there. Yeah? What's the highest one? 5, perfect. And this one here is 5. Brilliant. Okay. we can choose, let's choose this box. What is coming into this box? Only C. So it's got to be 5 plus 6, which is 11. Perfect. Okay, what is coming into this box here? We have 2 coming in. Okay? So we've either got 5 plus 7, which is 12, or 5 plus 3, which is 8. So which one are we going to use? 12, absolutely. So for each one, we're always looking at what is the highest one, okay? Now, let's have a look at G. How many ways can we get into this bit here through G? There's only one, isn't it? It is only G. So 12 plus 2? 14. Perfect. Then, how many things need to go into here? 2. So remember here, we can either go in this way or in this way. Yeah? So if we go in the way, going through F, there's going to be 11 plus 10, which is 21. Or if we're going the way using the dummy, it's 12 plus 0, which is 12. And we're going to use the highest one, 21. Okay, then lastly, to get to the last place, we can either go through I or H, yes? Okay, so what we're going to do is we're going to have a look. 21 plus 9, if we go through I, is 30. Or I've got 14 plus 1, which is 15. The highest one? 30. Perfect. Okay, everyone, so this is called a forward pass. And what we've done is we've started here and we've gone all the way to the front. So this is the early event times, okay? This is the earliest that an event can start. And this will make more sense because we're actually going to draw this on a really nice graph, okay? It's actually called a Gantt chart. We're going to get to that soon. As I said, we're going to bring everything together. We just have to understand what's happening. Okay, so now we're going to have a look at the bottom of each one, the bottom row. So now we have the bottom row. This is called a backward pass. And this is used to calculate the late event time. So this is the exact same diagram as earlier. And what we're going to do is we are going to go backwards, okay? So here we go. So the sync node, this is the sync node. It's the last one, okay? This always has to be the same, okay? If the late time is 30, the early time is 30. It just has to be finished at 30. Right, and now we go backwards. Now, when we go backwards, we choose the highest number still. So when we went forward, we chose the highest number. When we go backwards, we choose the lowest number. I think I said that completely wrong, didn't I? Right, no. When we went forwards, we chose the highest number, yes? Yeah. When we go backwards, we choose the lowest number. Everyone happy? Okay, so let's go backwards. First of all, from 30, if we go back one, what do we get to? 29. Brilliant. Now, if I go back one, I get 27, yes? There's also another way here. Have I filled this in yet? No, so I need to go back again and make sure I fill it in step by step, okay? So from 30, if I go back 9, what do I get? 21. Okay, now for this one here, I can either do 21 minus 0, which is 21, or 29 minus 2, which is 27. Which is my lowest one? 21. So that's how I get 21. Okay, because that's the smallest. Now, this node only depends on F, so I can just do 21 minus 10. Perfect. Now, what is 21 minus 10? 11. Okay, so now, if I have a look at this one, there's actually 1, 2 coming into this, isn't there? It's either 11 minus 6. Okay, 11 minus 6 is 5, or we could do 21 minus 7, which is 14. The smallest one is, in fact, 5. Then, then this one here. I can do 21 minus 3, which is 18, or 5 minus 0, which is 5. And then for the last one, this is always going to be 0, but if we, because it has to be 0. Okay? So the source node is the starting, the sink node is the ending. And there we go, we filled it completely in. Right, now test your understanding, please. Have a look. This diagram's half completed. It's 3 marks. You've got to find V, W, X, Y, and Z. Off you go. Right, so let's have a look now then. So, first of all, it's always easier to start and have a look at the top row. So, we've got 0, 8, 8, and then we've got this one here. Now, here we can see we've got 8 plus 8 is 16, or 8 plus 7 is 15. The only two that come into here, we're going to choose the highest one. So, therefore, V is going to equal 18. Sorry. 16. What's 8 plus 8? Keeping you all on your toes. Okay. Now, for W, if we have a look, the only way to come in here is there's 3 ways. We have 21 plus 4, which is 25. 19 plus 5, which is 24. 22 plus 2, 24. We're going to go for the highest one, so that means W is in fact 25. Brilliant. Okay, now we're going to have a look at Y. Okay, the only way to get into here is 21 minus 0, which is 21. Or we could do 25 minus 5, which is 20. Now, which one are we going to choose? We're going to choose the lowest one of 20. Now, into X. Remember, if we're going backwards and we're going into X, we've just got this one and this one. The top one's not coming in. The top one is coming into X. We're going, backwards. Brilliant. So, we're going to have 25 minus 2 is 23. 27 minus 3 is 24. Which one is the smallest? 23. So there we go. Okay, we have one more to do. Brilliant. Okay, so this one we want Z. So what comes like backwards into Z? D, E, F. Yes? So we're going to have 16 minus 7 is 9. 20 minus 11 is 9. 23 minus 10 is 13. The smallest one is 9. Is that right? Oh, the dummy. Oh, that is also coming out. 8 minus 0 is 8. Absolutely, that is 8. Watch out for that. So, as you can see, the arrows are all pointing all this way. Those are the ones we have to look at. Please use your highlighter when you're trying to figure this out, okay? That could have been a close call. Very easy mistake to make. Well done. Okay, so what we're now going to look at is we're going to look at what critical activities are. Critical activities are when the early time is exactly the same as the late time. For example, in this question, we have 0, 0, 8, 8, 8, 8, 16, 16, 21, 21, 35, 35, 25, 25, 27, 27. These are our critical activities. And normally our critical activities will form a critical path. Now we're going to come and look at why this critical path is really important. We're just going to calculate what it is, and then when we start drawing these Gantt charts, again, this is all going to fit together, okay? So here we go. What we're going to do is we're going to identify critical activities. So to begin with, everyone has this slide. What I would like you to do is I would like you to do all of the late times and early times for the events. And then we're going to identify all the critical activities and a critical path. Off you go. Okay, so let's have a look at the answers. Okay, so the answers are 0, 0. Okay, then we're going to have 6. 6 plus 8, 14. This one is 3. So I've got 3 plus 0, which is 3, or 6 plus 7, which is 13. Okay, 3 plus 4 is 7. 14 plus 5, 19. Okay, so now I can do 19 plus 2 is 21. 13 plus 9 is 22. 7 plus 8 is 15. So I'm going to go with 22. 19 plus 8 is 27. So I can do 27 plus 1 is 28. Or 22 plus 7, which is 29. I'm going to go with 29. Any questions with the forward pass? Right, backward pass. So we know we're going to start at 29. Okay, so backwards, this is going to be 28. 29 minus 27 is 22. Backwards again. Now, if I look here, I can either go 28 take away 8 is 20, or 22 take away 2 is 20. Luckily, they're both the same. 20. Then from 22 backwards, take away 9 is 13. 22 take away 8 is 14. Okay, so we've got 13 take away 0 or 14 take away 4. Yeah, which is 10. Okay, here we've got 20 take away 5, which is 15. Now, 15 take away 8 is 7, or 13 take away 7 is 6. So I'm going to go with 6. Perfect. Now what we need to do is identify the critical activities. So the critical activities are, now where's the next one where the early event time and the late event time matches? 13, 13, 22, 22, 29, 29. So how we would write that is A, D, G, L. These are the critical activities, and this is how we would write the answer. Okay? We'd write the critical activities are A, D, G, and L. Perfect. Oh. Okay, we're going to do one more, and this time we've got more than one critical path. Give this one a go, and then I'll show you how we find the answer. Off you go. Okay, so what we notice about this question, nice and easy. It's actually all of the early times are in fact also the late times, okay? So what we're going to do is, this means that all of the activities are critical and we have 2 critical paths. So we can go from 0, A, D, E, G, I. Okay, so A, D, E, G, I, or B, C, F, H. B, C, F, H. You might go B, C, F, G, I, and you could be A, D, E, H. That's also acceptable, okay? But basically, all of them are critical activities. Okay. Oh. Right, we're going to look at float of an activity. Now, I just want us to imagine, okay, this is what's happening. Now, to determine if, sometimes, as we've just seen then, We know that if the early event time equals the late event time, it is a critical activity. Sometimes they'll give us questions where we need to physically work it out. And we can work it out. You remember earlier we had that question where we had to work out X, Y, Z, and W. Sometimes we might only have part of a graph, and the way we work it out is by using this formula. Okay? So a critical activity has a float of 0. And how do we work out our total float? So the latest finishing time, so we go backwards. Are we ready? So let's say we have our activity A. We look at the event times before and after, okay? So we're going to do this. Watch this. This one, okay, which is our latest finishing time, minus how much the critical activity is, minus our earliest start time, okay? So we're going to go backwards like this. So for example, you can write this down, but I just find it easier. For A, we're going to do 5 minus 3 minus 0. What do we get? 2. Okay? For B, we're going to have 5 minus 0. 0. For C, so if we look at C, we're going to do 11 minus 6 is 5 minus 5, 0. Now we already know this is a critical activity because we know the early event time is equal to the late event time. Okay? Then we have D. Now for D, we're going to do 21 minus 7 is 14 minus 5 is 9. Perfect. For E, 21 minus 3 is 18 minus 5, 13. F, 21 minus 10 is 11 minus 11, 0. G, 29 minus 2 is 27 minus 12, 15. H, 13 minus 1 is 29 minus 14, 15. I, 13 minus 9 is 21, minus 21, 0. Okay? Now sometimes they'll ask you to calculate the late, duration, early. You don't have to do that if you remember this up here. Okay? So now we're going to have a look at that and practice it. Okay, so what you're going to do now is calculate the missing early and late times and hence complete the diagram. Okay, please make sure you read what's happening. Then you need to calculate the total flow on activities D, G, I. And then you've got to list the critical activities. This is a 9-mark question. You've got 9 minutes, off you go. 5 plus 9 is 14, or 17 plus 0 is 17. We go for the largest one, so we get 17. 17 plus 2 is 19, or 20 plus 0 is 20. We're going to go for the largest, which is 20. 20 plus 14 is 34. 26 plus 9 is 35. 23 plus 10 is 23. The largest is 35. So there's the forward pass. Now we know our sync node is exactly the same. Going backwards, if we go to 20 minus 2 is in fact 18. Then we're going to have 20 minus 0 is 20. 25 minus 3 is 22. We're going to go with the smallest one, which is 20. We're going to have 18 minus 0 is 18. 20 minus 3 is 17. Smallest, 17. 25 minus 10 is 15. 20 minus 6 is 14. The smallest is in fact 14. Okay, so there we go. We filled this in. Then it says calculate our total float for D, G, and I. So for D, we're going to have 18 minus 9 minus 5. So 18 minus 9 minus 5, which is going to give 4. We're going to apply the same for G. We're going to have 25 minus 10 minus 8, which is 7. For I, we're going to have 25 minus 3 minus 20, which is 2. Perfect. So this is why we need to understand how to do this. Sometimes we know if it's 0, it's a critical activity, but we also have to look at the floats. And then C says list the critical activities. So if I have a look on my path, 0, 0, 17, 17, 20, 20, 20, 20, 26, 26, 35, 35. So we're going to go B, E. Now you'll notice with the dummy here, they are going to be the same. It shouldn't affect, because then it's J, M. So we're going to have B, E, J, M. The dummy does not affect anything. We just have to write it in there so the network looks good. So that's 9-mark question. Well done. Okay, how does everyone feel? Okay guys, so what we're now going to look at is gantt charts. So sometimes in the exam they're called cascade charts. And what this is going to allow us is to present all the information that we've just found in a chart. It's really simple. Now they actually use these types of charts for scheduling people's activities, okay? If they've got to do X, Y, Z, A to Z, how many workers is the minimum that are needed? Thank you. How many workers are the minimum needed to complete this? Okay, so that's what we're going to look at. We're also going to look at something called scheduling charts. So there's 2 types of charts that you could be asked in the exam. One is gantt or cascade, the other one is scheduling. They look very similar, they're completely different. Okay? Now you're going to love this. We can't really do it on recording, but we are going to do some cutting. Okay, we're going to make some mini things. It's going to look really beautiful. I'll show you what I mean. Okay, so here we go. We're going to have a look at drawing a gantt chart. Now, it's really easy to draw a gantt chart, okay? So, sometimes they use floats. Okay, so there is a method to do this. We're just going to do my way. Okay? We don't have to worry about all these formulas. Okay, it's really simple. So, step 1, we have a look for our critical path. Now, we know that our critical path is where we have, and to use a technical term, a float of 0. Okay, or in other words, when the early event time is equal to the late event time. Sometimes we might have more than one critical path. Okay. Okay, what one have I not missed out, but kind of missed out? Yeah, this one as well. Okay. So, how do we know which one to choose? Now, you can see here, I've got 0, 0, 5, 5, 0, 0, 5, 5. I've gone up and down. This is where we make a classic mistake. Okay. Because if we actually have a look, if we look at the float for the total float of A, 5 minus 3 minus 0 is 2. So is this one actually part of our critical path? No, this is the biggest mistake people make because they think to themselves, oh, well, here is 0, 0 and 5, 5. But actually, the critical path it's pointed to is B. Because remember, this dummy is weighted 0. So this is actually the whole of B. It's just taking a quick, askew. Yeah? So our critical path, so this is where we get the most mistakes here. So make sure you know that your critical path only contains critical activities with a total float of 0. Do you see how easy it was to make that mistake? Yeah, that's why I did it that way. To show you guys, because everyone always looks to A first, don't they? Let's face it. Right, so our critical activities is B, C, F, I. Perfect. So now when we draw this, we know critical activities always go on the top row, okay? Always go on the top row, because it's our critical path. So 0 to 5 is B. Are we all happy with that? Yeah? 5 to 11 is C. How am I getting these numbers? Where are they coming from? 11 to 21 is F. And 21 to 30 is I. Okay? So here I have drawn my critical activities. These have to happen without a break. Let's say we decide to have a cooking lesson in this class. Okay, we're having a cooking lesson and we're going to make some cakes. Now, for the cakes, it takes 4 minutes for someone to mush up the butter. Yeah? We can't add the carrots to the mushed up butter until we've mushed the butter. Yeah, because we're making a carrot cake now. Does anyone know? Okay? Then we can't add the flour to the mushed up carrot and butter until we've mushed up the carrot and butter. And we can't mush the carrot in the butter until we mush the butter. Yeah? I don't know where the word mush came from, it just really felt right. I don't think it's the technical term. So this is why. So is everyone happy with the step 1? Find critical activities, critical path. You'll see there's never any gaps in the critical path, is there? And remember, these activities are all dependent on each other. Now, in a cascading gantt, what we now do is we start alphabetical order, and each one will now have a new line. Okay? And I'm going to show you what else we do. So each one that's left, what do we have? 1, 2, 3, 4, 5. Everyone happy? We've got 5 letters left. So how many lines should we go down? How many rows? We're going to have 5 new rows. Everyone happy with that? Okay. We're now going to start at A. Now, you remember we had this very important, when we look at the total flow, we look at this order. It's always this way. Yeah, and when we do the total float, we work backwards. These are the numbers that are going to help us draw our boxes now. Okay, and this is how it's going to look. I'm going to do A for you. So for A, we have to start at 0. Everyone happy with start at 0? How long is it? 3. Perfect. Okay, it's 3 long. This is A. We haven't finished though. It has to be done by 5 minutes. So we're going to use some dotted lines. Okay? Now, what this means, and this is really, really exciting, everyone. I'm not sure if this will work, but I'm going to try and see what happens for the YouTube. It'll definitely work if we cut out a piece of paper, okay? So, let me just try something. Let's insert a shape. I'm really hoping it's going to work. Okay. Okay, perfect. Yes, okay guys, this is shape A, isn't it? It's a little bit strange because it's not completely the same size. Let's pretend it is. Everyone happy? How much is A? 3. So what this is saying though is we could start A immediately, okay? So let's say one of you are helping. Okay, let's say one of you are mushing the butter. Okay, now some of you are chopping apples because we need to put some apples in the carrot cake, but we don't need to put the apples in until the butter's completely mashed. So, for example, you could start it right away and then have a 2-minute break. Yeah? Or you could start it at 1 minute, couldn't you? And you'd have a 1-minute break. Or you could have a 2-minute break at the beginning and start it at 2 minutes, and you'd still be finished in time for it to be done at 5. So whenever we put this is a slider saying that we could essentially fit this activity in here at any time, as long as we don't go out of the lines. Do we understand what this represents? Okay, we have to be really visual with this. What do you think of my box? It's pretty innovative, isn't it? Okay, let's leave that there. Right, so let's do the same with, so A, check. We did B. What's the next letter in the alphabet? C. Done. D. When do we start D? At 5. How big is it? 7. Okay. So then we do the middle one. Where could we maybe finish it? 21. So what do we put here? our dotted line, and this is D. Now what we're going to do is I'm going to show you oh, 1 second. Oh, wait there, guys. I'm just trying to make that shape again. Yes! Okay. Sorry, this is so exciting. Okay, so here is our shape, D. Okay. Now, you can cut up a tiny piece of paper to slide it. We will need to start sliding them during the lesson. Okay. So D, and let's just make sure. For D, this is saying that essentially, can you see that we could actually start it at 14 minutes and still be finished in time for 21? Yeah, because does anyone know what D stands for? The dishes. Okay, we've got to butter the dishes before we eye for input them in the oven. Okay, I have no idea, but you know, I'm just making these up, yeah? But do you understand the context, okay? So, can we put it into the oven if we didn't do the dishes, butter the dishes so that the cake doesn't stick? Yeah, do you see what I mean? This is saying, though, that we could start it here, we could also move this around, yeah? Are we happy with this? Okay, perfect. Okay, A, B, C, D, E is, where does E have to start? 5. How long does E take? 3. And when could we finish E? Oh, I've put 3 instead of E. It's pretty much similar because it's just backwards, isn't it? Okay, so then I've got my dotted line for that part. Okay, so now, do I need to draw a little box and move it round, or are we all happy with the sliding? Happy? Okay, so next up, A, B, C, D, E, F, G. Okay, G starts at? G starts at? Where does G start? 12. Remember, guys? Top, middle, bottom. Look at G. Top, 12. Middle, 2. Bottom. Yeah. Everyone happy with this? Okay, we use the same rule that we use for the total float. You know when we have to make a 0? Yeah? Because I said so. No, I'm joking. Why is it top, middle, bottom? Event time, total time, late event time. What's the earliest time you can start the event? What's the latest time you can start the event? What is the total float? What is the latest finishing time? All of this, because you remember when we looked at this as a graph. For example, I is dependent on D and E. Yeah, look at I. It's dependent on D, E, and F, actually. Yeah? Next, after A, B, C, D, E, F, G, H. Okay, when does H start? H starts at 14. It's 1 square. Oh, I need a different colour. H starts at 14. It's 1 square. H. And it ends at 30. Absolutely. And then lastly, let's go for purple. It's I. I starts at? Oh, we do have I. Perfect. Already did it. Brilliant. Isn't that fantastic? Yeah? Okay, are we ready for a challenge? Question. The challenge is now. What is the minimum number of people I need to help me to complete this cake? Have a think about this, off you go. So this is a Gantt chart. What I'm now going to look at typically is scheduling diagrams would also help us find this, find the minimum workers. Now we had a few different answers, 2, 4 and 3. Okay, so first of all, everyone's in agreement that only one person can do the critical path, and they're not going to have any breaks. It's just life, right? So imagine I've drawn that critical path here. So we're moving on now to something called scheduling. Okay, so what we've just drawn is a gantt or cascade. This is now an example of scheduling. Scheduling, everyone's happy, we have the critical activity. Okay, so then A, is everyone happy that A could fit in the first three? D, okay, now D has to start at 5, so we could put D here, yes? There's a gap, is that okay? Yes, it just means you're going to have a 2-minute break. Okay, then E. I'm going to go yellow box. E is 3 long, okay? How could it couldn't match the shape? I mean, I literally just drew. Oh. 1 second, guys. Right, this is... Okay, let me just draw it again. Nobody panic. Ah! Okay, I'm panicking. Right, there we go. Right, a yellow box. This can't be that difficult. Yes, okay, so everyone, this is 3, yes? Now with this, remember, can I start it here? Yes, so what I'm going to do is I'm just going to schedule it right after. No breaks for you. Okay? Then we have G, which is 2. Oh, I mean, does it look like a rectangle, guys? Honestly. Right, wait there. There must be another way to draw a shape. Does anyone know how I work this?
What if you draw it on top of the G box?
Oh, okay. Well, we'll just go with that then. G is 2. Oh, no. Right, let's just do this. Oh. Sorry. Okay, let's just do this again. Let's say it's this. Okay, G is 2. Now, can I start it here?
Yes.
Okay, there we go. Then, last box is a H, which is pink. Oops. What is happening? Okay. I know. Okay, pink is 1. Are we happy? Okay, and we know that we could slide H, it would fit here, wouldn't it? So technically, what is the minimum amount of people I need to help me make this cake? 2. Absolutely. And what we've done here is created a scheduling diagram, because what I've said is, some of you have said 4 people. Okay, well, we can tell that when you do a business degree, you're going to lose a lot of money. Okay? Because you've got to think about it. If we're doing business, you're going to hire people, yeah? You want them, you could even add some extra jobs here. Because you could see this one is continuously working, this one has a little bit of time. But the minimum amount of workers we need to complete this cake is 2. Right, so this catches a lot of people out. This one catches a lot of people out. Sometimes they give you a Gantt chart. We've just looked at drawing them. Sometimes they give you a Gantt chart. And they say this project's got to be completed in 20 days. Determine 2 activities that must be happening at midday on the 9th day. Okay. If they said midday on the 9th day, who would draw 9.5? Be honest. Who would draw 9.5 if it said midday on the 9th day? Yeah, thank you for those of you who are honest. Okay, midday on the 9th day, though, is actually between 8 and 8.5. This is why. Midnight on the first day. all the way, the whole day one is completed in here. Do we understand? So if I was to say midday on the first day, it's actually in between 0 and 1. Because midday on the first day is 12 hours after we started. 12 hours after we started is in between 0 and 1. 0 is 0 hours, 1 is 24 hours. Yeah? Watch out for this. Okay, so it says here, determine 2 activities that must be happening at midday on the 9th day. 2 activities that definitely have to happen. B, 100%. It's always going to be part of your critical thing. And midday on the 9th day, midnight on the 9th day starts here because we finished day 8. We now start day 9. We finish day 9 here. So in the middle of day 9 is here. Okay?
So you start.
So when we reach the day, when we reach this number, this is saying day 8 ended right there. Okay? So B definitely has to happen. Okay? And then when we look, so then we start imagining, okay, so F, we could slide here. Oh, is it still in between that day? Yeah, and this is F, isn't it? So F will 100% have to happen. Okay, let's just move F out of the way a minute. Then, we also have G. Okay, if we look at G, can I move it here?
Yes.
Does it have to happen on that day? No. So this is sometimes where we have to really visualise. I mean, these boxes I'm drawing are great. Okay, really good, interactive, and you can see what you have to move. And that actually, the only 2 that definitely have to happen is B and F. Name 2 additional activities that might be happening on that day. C and G, because we could decide that actually, no, we want to start it here. So it could happen there. And we also know, well, let's get a nice another pretty box. C, we could also move to here, couldn't we? C, we might say to start at 6. Yeah? Okay, so there we go. Nice and simple. Okay, now the other type of diagram is scheduling diagrams. We've just already spoken about scheduling diagrams. If you want to pause and read this, you can. I have no idea what it says. It's just a reminder, really, doing that. So, here we go. This is a schedule here, and you can see every A, B, C, D, E, F, G, H, I, J. This top one is what we like to call a gantt or cascade. The bottom one is what we like to call scheduling. Now we can see here what has happened. So this is one that's pre-done for you. Okay? So first things first. You know that the critical path will always be the critical path. It's just, that will always happen. And then all they've done is they've used the sliders and see if it fits in. Now, can you see here that D and E, they've managed to put E before D? That's okay. Okay? We could have, though, put D here, and then would E have fitted in?
Yeah.
Yes. Okay? The only time it matters on the order is if anything is dependent on anything. Double check that. Okay? Now, in the exam, anything that we're not doing, shade. Shade that in. Colour it in as inactive. That is to show, because sometimes, you see earlier when we had all the gaps, if I was to draw this, and we have B, E, D, G, and then we have that. Sometimes it gets confusing. Please shade. Okay? Handy tip for you. When in doubt, shade it out. Yeah? Okay then. Right, and I think we've only got like 1 or 2 more things, and then we're going to do a test your understanding. Right, one more thing. Here we go. So, If we ever look for the lower bound, it will always say the sum of activity times in a question. Okay? The sum of activity times is the total duration. The total duration. Now, if we add all this up, what do we get? So the total duration here is 48 when we added them all up. Okay, this is like, you know, the weight of the entire network. So what we're going to do is we're going to do the weight of the entire network, 48. Okay? Now, what do we divide that by? Do you remember the sync node at the end? The sync node at the end? We have the total time there. That's basically the total time that the project will take to complete. We divide it by the total on the sync node. Okay, so the sync node is the last node that we see. We divide it by the total. Now, here, it tells us that 25 days was the sync node for the previous, this is where this has come from. Yeah? So we're going to divide this by 25. What is our answer? One point something, isn't it? 1.92. Okay, now I knew it was going to be 1 point high something because 25 times 2 is 50. Yeah? So, what's the minimum amount of workers that we're going to need? 2. Because we're going to have to round up. We can't have 1.9 of a person. What if my answer was 1.3? How many workers? It's still 2. You can't have 0.3 of a person, can you? Okay? If you need 0.3 of a person, that means that you still need a whole person. There might be some wasted time. You might have to give them some more jobs, be a bit innovative. Okay? This is what we're going to have to do. And this is how we work out the lower bound. It's always the way. Now what we're going to do is we're going to bring this all together and we're going to do one question as a team. So let's do this. Okay, here's a question. You are going to A, B, C, D, E, F, G. Okay? Going to calculate all of this. I reckon this question is at least 10 marks. You've got 10 minutes, off you go. Okay, so what we're going to do is, here is a typical exam question, and we're just going to go through this step by step. So, calculate the missing early and late times and complete the diagram. Okay, so we're always really going to start from, try and go alphabetical order, because you'll find that normally that's the best way. So we have to go, we've got 9. From here, I can either do 9 or 11. Which one am I going to choose? The highest one, which is? 11. Okay, from E, I can either go 14 or 11. Which one am I going to choose? 14. F, I can either go 13, 12, or 14. Which one am I going to choose? 14. Done. Okay, perfect. Right. So that's our forward pass. Now going backwards. Okay. Let's have a look at what comes out of E. If I have a look at what comes out of E, I've got 3. Can everyone see? I'm going to calculate all 3 right now. So 23 minus 9. 14. 30 minus 15. 15. 14 minus 0. 14. What am I going to choose? The lowest, which is 14. Perfect. Okay, at B. I'm at B. What? Oh, no, I'm not at B. Yes, I am at B. What goes into B? Only these 2, right? Yeah. Yes. Okay, so either 14 or 14 minus 2, which is 12. Which one am I going to choose? 12, the lowest. Brilliant. Okay, what goes into C? This one or this one? So remember, going backward pass. 14 minus 1 is 13. 12 minus 0 is 12. So there we go. Filled it in. Okay, did everyone get the same answer as me? Yes. That's what I'm talking about. Brilliant. Next one. So, now what are we going to do? We are going to okay, so now what we're going to do is list the two critical paths. Now remember, critical path has a float of 0. So let me just rub out everything we don't need now, so it's easy to see what's happening, or else it gets too colourful. Okay, here we go. So now I'm going to use yellow. So remember, even though most of the time it is between 0, 0, 10, 10, just double check that this is a critical activity, because the float will be 0. Okay, 0, 10, 0, no, 0, no, 10, 10, 0 is 0. Okay, and then 10, 4, 14, this one is 0. Can we see here that 10 plus 11 is not 23? So D is not a critical activity, yeah? Okay, what is the H? This one is, isn't it? If we go up H. Okay, and then K plus 7, yes. Okay, now it said that there are two critical paths. So if I also look, I could have gone from E down to F across to L. Yeah? Okay, so when I draw these, first of all, explain what is meant by a critical path. What is a critical path? Critical path is a path that contains critical activities. And critical activities have a float of? Okay, something like that's perfect. Okay, D. Oh wait, then we didn't write B. Right, the two critical paths are. So we could do A, E, H, K, or A, E, F, L. Yeah, A-E-L, sorry, there is no F. Completely correct. Okay, so we need to make sure that with the critical path, a few key words that we're looking for is float, 0. Okay, what is a path? Okay, and you know, that kind of things, yeah? And about the critical activities, they have to happen when they happen. Okay, A, B, C, D. Calculate the lower bound. Okay, so we should have added up the total network. And when we added up the total weight, we get 110. We're going to divide that by the number in our sync node, which is 30. So this means 1, 2, 3 and 2/3. Yeah, and 3 2/3. So that's 3.66 recurring. So minimum amount of workers is going to be 4. E, list the activities that must be happening on day 20. Okay. Can we do that without drawing anything? No. Yes, maybe. We might be able to, but it's going to be complicated. So let's start drawing things. So step 1, 0 to 10. This is my A. Then E is 10 to 14. Then if we do H, 14 to 19. And then K, 23. Yeah, I have drawn H wrong, absolutely. Where should it go to? 23. Yeah, and then K is 23 to 30. Okay, now it's really important. The next lot of critical activities, I'm just drawing a Gantt chart quickly. That's all I'm drawing. Is going to be after. So we need E and L. So E is done, and then L is going to be 14 to 30. Okay, so there it is. There's my critical activity. We put that on the second one. Right, now we start alphabetical order, don't we? So, A, now we have B. B starts at 0. Where does it finish? 9. And we use our dotted lines, yeah? Okay, up to 12. C starts at 0. It's actually exactly the same, isn't it? Yeah? So A, B, C. Okay, next up is D. Starts at 10. It's 11 long to 21. And we have it dotted up to 23. Wait, am I on 20 or 21? I think 21 is here. Can everyone see what I'm doing? Yeah? Okay. Then A, B, C. This is D. E, what's next? F starts at 11. F is too long, but it could finish at 14. I'm not doing the question wrong. I'm not even on part G. All I'm doing is I'm having a look at E, list the activities that must be happening on day 20. I'm just drawing a Gantt chart so we can visualise it for everyone and going over the skills again. Yeah, C, I've gone wrong. Duration's 11, so it should be here. Ends at 9. Perfect. Okay. Wait, what? Duration is 11. Oh. Duration should be here, and then it ends at 12, absolutely. Okay, sorry guys. Right, so F, done. D, E, F. What's the next one? G. Okay. G starts at 11. It's 1 long, and where does it finish? 14. G. H, done. I. Starts at 14. Is 15 long. It ends at 29 to 30. It's I. Okay. J. J is actually exactly the same. Starts at 14, 15 long. Okay, and then J. K, L. Okay, so we've done it. So this is a Gantt chart. It hasn't asked me for this in the question. We're looking at this because it's an example. So list the activities that must be happening on day 20. Now remember, day 20, okay, is in fact in between day 19, is in between the numbers 19 and 20. Okay, so we can see here that the activities that definitely have to be happening. H, L. What else needs to be happening? D, I, J. So we can see here that the activities A, B, C, D, E that definitely need to be happening are H, L, D, I, J. Now to make it easy for the examiner, what we're going to do, we're going to write this in alphabetical order. A, B, C, D, E, F, G, H-I-J-K-L, okay? Make it nice and easy for them. Yeah? Now, F, comment on your answer to part E with regards to the lower bound you found in part D. What does it tell me about the lower bound? It tells me that it's not going to be possible to find a solution with 4 workers. If we have to have, between that days, 5 things happening at the same time, okay, it's not possible. So it tells us that it will not be possible. Not possible for 4 workers. We need 5. So if we need 5 workers, now this is where the next part comes in. The next part says we need to do a scheduling diagram. If we need 5 workers for our scheduling diagram, do you think it's going to be 5 rows?
Yeah.
Absolutely. Okay, so here we go. Now what we're going to do is we're going to play jigsaw. We're going to move things around, yeah? So let's imagine. Okay, remember this one here is not part of the question. Did I spell gantt wrong? Has it got a H in it? I really want to put a H in. It doesn't, does it? Okay. So, here we go. Right, so everyone's happy that the first row is A-E-H-K. Yeah? Okay. That's K. H. E. A. Okay, that's the first row done. Done. Okay, this is the schedule. Okay, so L has to be on its own as well because it is a critical activity. So there's L. So now we start on the 3rd row.
Can we just leave L at the bottom?
With B. Yeah, you could leave L at the bottom if you wanted. Well, actually, I don't know. Yeah, you can leave it at the bottom. Okay, so now we're going to do B on the 3rd row. Now, next is C. Even if we moved C, like slided it across, it's not going to fit. So C is going to have to be on its own row. Now D, if I, 1, 2, let's say this is D, here, D we could slide across so it will fit in. Okay, we could slide across or we could bring it down. It fits nicely actually next to B. Okay, so that is now D. F, where would F fit? Here, next to C. G, we could slide G across and it'd fit right there. G. And then, could we fit on this one an I or a J? Yep, I'm going to fit I in. And then on the last row, we have to fit in J. That's a terrible picture. What we can see, though, is that we have how many rows? 5. And we've worked out that we need 5 workers minimum. Okay, and here is a mark scheme so you can see it in more detail. Now you can see here that I is up here, L is here, and with the G, even though they've written it like this, they only put one way. As long as your G slides into place, you can put it wherever you want. This is why sometimes decisions are really difficult to mark, because there can be more than one solution, as long as it doesn't go across over 5. Okay, so I've put that there. Right, well done. We've now completely finished CPA, critical path analysis, all done. We're now going to do the exam question packs that we've got, yeah? Okay, congratulations. D1 is finished.